Welcome to AI, Government and the Future, a podcast by Corner Alliance. We explore the intersection of artificial intelligence, government and the future. We work with government to create results. We ignite your agency's mission by helping you to design and implement high-impact and innovative federal programs in AI, broadband, cybersecurity, public safety, and more. Being a government ally is at the core of all we do.
Welcome back to AI, Government in the Future. I'm your host, Marc Leh. Today, I'm excited to be joined by Dr. Armada Shehu, where we'll discuss large language model opportunities and risks for government agencies. Armada is a renowned expert in AI and machine learning with a distinguished career that bridges the gap between academia and government innovation. She currently serves as a professor in the Department of Computer Science and the Associate Dean for AI Innovation at George Mason University in Fairfax, Virginia. Additionally, she's the Associate Vice President of Research for the Institute on Digital Innovation. With over 180 technical papers to her name and multiple prestigious awards, including the National Science Foundation's Career Award, Armada has made significant contributions to advancing AI research and its real-world applications. Her work is especially focused on tackling complex real-world problems from cybersecurity to biomedical engineering, all while driving AI innovation towards government applications. Welcome, Armada. We're so happy to have you on the podcast today, and hopefully you're having a great afternoon.
Happy to be here. Good afternoon to you too.
Great. Well, I think to begin, would love to learn a little bit more about your background. Do you mind sharing with our listeners how your journey into AI and machine learning began? And, what initially drew you to focus on applying these technologies to complex real-world problems and problems within government?
Yeah. Thank you for that question. I think when I was an undergraduate student, I didn't have much of an appreciation for AI research. I was just your typical, computer science student, and was more drawn towards the theoretical side of computer science. I loved proofs, if that appeals to anyone. But when I started my PhD program, I saw very clearly this connection between foundational computing research and the applied side of things. And that started to appeal to me greatly. So I ended up in a lab that had sort of one leg in foundational research and one in applied research. And it happened to be an AI lab. So that's how I ended up doing AI research, graduated, and then joined George Mason University in 2008 at the height of the housing crisis as an assistant professor. And since then, I have continued being an AI researcher. And as I tell folks, I'm just happy to continue to be in the right field because I've been in AI when it had a lot of downs, right? More downs than ups.
That's great. Well, and Corner Alliance, we do a lot of management consulting services with leading research and development labs within the electrical engineering and computing and biomedical fields. Out of curiosity, what were some of those foundational research methods or skill sets that you developed in your academic years that you've been leaning into most recently, developing on more application side AI work?
Yeah, so I started with a focus on complex dynamic systems. So systems that have a lot of degrees of freedom. So think of robots with a lot of joints and links connecting the joints, and molecules with a lot of atoms and bonds that connect the atoms. And these are very complex systems because they're big, they have a lot of degrees of freedom, and they engage in quite interesting behaviors. So when we talk about modeling the systems, we talk about finding out what states they can reach, where are they functional, even though that's an ill-defined term, how do they navigate between states in their state space. So I started with, I would call them hardcore optimization research. So the part of AI that is sort of underneath the hood of a lot of the complex problems, even deep learning. And then gradually went into machine learning, again, more from the optimization side of things, thinking about large feature spaces and how to extract knowledge, domain knowledge, plus data knowledge, and build hybrid machine learning methods, and then ventured into deep learning. And in deep learning, we have done a lot of work on both the architecture side, so thinking very deeply about the architecture of the neural networks, to capture specific aspects of the problem. And then also we've been thinking about how do you inject prior knowledge into the network. So we're one of the few labs, I have to say, that don't believe that data is the only way, that you'll have enough sufficient data to capture complex physical processes. So we always want to inject into these models prior knowledge, what we call priors, conditional priors. So there's a lot of very foundational research that we do in that space in terms of applications. Anything that is complex appeals to us. So anything that seems hard. So it can be civil engineering, the design of a bridge with very specific criteria, very constrained optimization space. It can be in transportation, for instance, forecasting. We had a cool project here in Northern Virginia. We were trying to understand, predict traffic speed in the presence of work zones. If you drive around Northern Virginia, you're always frustrated. There's always construction going on. And since I've been here 2008, so we were training the model on historical data, but we were also injecting sort of the network of the roads, the graph, the structure, and where the work zones were. So any realistic problems, whether they are in biology or transportation or cybersecurity, anything that seems complex for us is fair game.
Yeah, well, I love what you said about, providing conditional prior or high quality data into machine learning systems or predictive analytics. And I think that is overlooked as kind of a utility or a role that government agencies and academic research labs are really well positioned to, take the time and leverage their collective expertise to kind of curate and validate the quality of data sets being used by, generative AI models, in the marketplace. And to build on your transportation example, two applications that are receiving a lot of interest, at least in my work day to day, would be, the development of digital twins, kind of simulating manufacturing processes or the performance of, electrical engineering components, whether it's, semiconductors or a, wireless communications network, things of that nature, or, simulating the traffic on a IP or broadband, radio. Having real world kind of calibrated data to assess the veracity or quality of prediction is something that maybe a lot of people take for granted that is going to be really important as these systems get more and more integrated into, I guess, what I would call mission critical applications that impact, hundreds of thousands, millions of people, like in a metropolitan area.
Yeah, absolutely. You've hit the nail on the head because, and I know the focus of the podcast is on government. I take a little bit of a different view in terms of sort of where the challenges are, just because I've started to talk to a lot of government agencies. They're very interested in adopting AI. But what we find over the years, and this hopefully is changing, but it hasn't changed so much, is the digitization challenge. That the data is just not in a ready form, and it's sort of hidden. It is informal, and so that is, I would say, the first battle towards integrating AI more in the day-to-day, whether it is for routine tasks or for really novel reimaginings of how the government does business.
Yeah, and that's a great point. I mean, just transferring and cleaning a lot of the data that would be leveraged by large language models is step one. I guess in your experience, do you see any sort of really exciting opportunities or challenges to transform the efficiency or effectiveness of government agencies through the use of large language models? I guess any specific examples that you and your team at George Mason have worked on recently that show exciting promise, things like that?
Yeah, so I have a lot of stories of sort of both successes and challenges, right? Stories of us rethinking, for instance, how we can change a particular task and either succeeding at that, such as this example with the transportation. This was data provided to us by the Virginia Department of Transportation, VDOT. It was historical data. We were also able to obtain publicly available data, and so you should always do that, and that's available. So this was not using large language models. It was using other types of neural network architectures, which don't get to be so much in the press these days in the news because everybody's talking LLMs, right? Everybody's talking large language models. So the first point I want to make is that the government needs to talk to the right people, so it doesn't think that every problem is solvable by LLMs. Sometimes LLMs are absolutely not necessary, and they're a very big hammer where all you need is something very precise, a scalpel. And so that is the case when talking to an academic lab, you'll get less of the hype and you'll get more of the, here is what the state of the art does. And that might not be an LLM, it might be a graph neural network. For instance, for this transportation problem, what we were doing is we were building on top of a graph neural network architecture with some attention layers so we could capture the sort of a connectivity of the roads, the connectivity of the work zones, and the connection over time, right? The coherence over time of historical data that we were obtaining. There's a lot of work we've done with other architectures, variational autoencoders. So there are a lot of other generative frameworks that are not large language models, that are not as large as large language models, and you can train them in-house and you can afford them in-house, and you don't have to worry about outsourcing your data, like revealing your data to someone, or you don't have to worry about hallucination, right? Now, of course, large language models are in the news because they are very popular. They were somehow made very popular, right? We've been using them for years, but it helps when you have a big company that brings more PR on it, right? For many researchers, it's not new. That's what we do every day. But there are a lot of opportunities with large language models for basically taking that sometimes knowledge that is fragmented in an organization. So this doesn't just apply to the government, right? So this can apply to a business, it can apply to a nonprofit, it can even apply to a university, right? So you have this knowledge spread across many offices, for instance. And if you have a large language model, and especially if you have that knowledge made explicit, like I talked about digitization, right? And the digital records of that knowledge, it doesn't matter whether it's PDF or text, but it needs to be electronic, right? Some electronic version of it. You can even handle recordings, even if you have recordings of that knowledge, right? So that's how flexible, how powerful sort of these models are nowadays. So if you have that, then you can learn the language, right? So the language, what is the knowledge that you have in your organization? And you can interact and you can ask questions, and you can have so many applications. You can have onboarding for new employees. Can you imagine that? Onboarding for new employees. I want to know how something is done. I don't have to go and bother 5 people, right? I can do that, and I can get on-demand knowledge, right? Because sometimes I can come up with very weird questions, and 3 or 4 people may say, well, I don't know about that. But if all this knowledge is encoded, is encapsulated into an LLM, then, I can get help when I need, and I can do that on a continual basis, and I can get better at what I do. This is low-hanging fruit, right? And then there are even more interesting things beyond just efficiencies, like onboarding. It can be that we want to really understand where should we make our next bet, right? What should be our next project? Where should we focus our resources? Can we ideate, right? What is the hypothesis? Where next? Imagine, for instance, if we want to figure out, maybe this is not so much for government, but for a nonprofit or for an industry, what is our best communication strategy? Where have we been most successful with donors? What should be our donor strategy, right? What are unique, successful characteristics of our strategies? And so you can actually train these things to suggest to you, to grab that knowledge that may not be explicit to you because we are not so good at connecting many dots, right? But these things have this memory, large memory encoded in them. And so they're good at connecting the dots. But they're only, I would say they're a first step, right? They're not replacing the human. I like to think of it that they're empowering the human so that then I can be better at my job, so that then I can look at that and say, and with the additional information that we have, here are 2 or 3 best ways forward that hopefully will be more successful. Then say, were I to base that on fragmented, rudimentary knowledge spread around the organization.
Yeah, I love that. Using LLMs to develop strategy, I think is not a common use case that people think of, because it is, currently being adopted for more, easily automatable tasks, for lack of a better term. I guess, Armada, from your perspective, in terms of developing a system or becoming an early adopter, whether you're a government agency, a business, an individual kind of looking to use these LLMs to optimize decision making moving forward, what would be your approach of beginning to organize your data or building a system? I guess developing kind of a series of prompts and packaging them in terms of a directory structure, like an object in a object oriented programming standpoint. Are there kind of early steps that people can take or organizations can take to begin leveraging these LLM capabilities for improved decision making from your perspective?
Yeah. So that's actually a really interesting question. And I've been thinking a while about this disconnect between, when you look at the data, they say everybody's excited, but everybody's also very afraid, right? Or they say all your employees, 75% of them are using these, sometimes secretly, right? And they're not telling you. But then when you're actually gathering the data, you're saying, I'm not really using in my day-to-day, in my company or in my agency. So there's this very weird disconnect. And there might be many reasons. One is that it's a very new technology, right? So everybody's kind of looking around and waiting for, what did you make work, right? Where did you get your ROI on it? And in general, especially industry is very cautious at that, right? But if you want to get started, there is one approach that I like, and it may not be the only approach because there's a lot of things that you can do in-house. But one approach is that you can partner with somebody to de-risk it first. And so academic labs can be one way. Industry can also be another way for government agencies, right? You can have a contractor and you can present a contractor or an academic lab some very specific use cases, right? You can even work with a partner to outline specific use cases to formulate them properly. And you can have your partner develop them with very specific, sandboxing and constraints that you have as an organization. And they effectively, what they do is they de-risk it, right? And they might show whether it's feasible or not, viable or not, for whatever reasons, they can bring it further down the pipeline. Now, one of the challenges with that, based on my experience as well, I have a couple of projects that I cannot reveal too much about because they're ongoing with a governmental agency, is that the very first stumbling block is, where's the data? So if they want to, you work together, you have a very specific use case, it's beautiful, crisp, formulated, packaged, and then you're ready on day one, and it's like, well, they don't know where the data sits. They can point you to some websites, maybe. They say, well, I have to talk to my guy because he does this thing, he goes in the field and he does this, and I don't know where. And that takes time. So I don't think we have an AI problem. We still have a data problem, and I don't think people really realize this. Once you have the data, it should be it should be simpler, because since we went open source and we have made it so easy now how to code in Python, you don't even need to code in Python anymore, right? You can have somebody teach you, one of these engines teach you, and then you can make decisions, higher level decisions. But once you have the data, then you can move a little bit closer. So I would say it's a multi-pronged strategy. First is organizations really need to think, where is my data? And to make investments to sort of change the culture of the organization. I know I'm sounding like 5 years ago, but this is especially a challenge with governmental agencies that I realized from my own personal experiences. And then formulate a couple of very specific use cases. You don't have to start with a very ambitious strategy. Ambitious strategy is great, right? But doesn't pay the bills. A couple of very specific use cases, de-risk them with a partner, whether that is through a competitive process, through a subcontractor, or whether that is a very tight relationship with an academic lab, over which sometimes you have a little bit more control and more continuous control and accountability. I would say these are the major takeaways. Now, specific examples, I can give you a couple of specific examples, but when you hear, for instance, everybody say, oh, there's a hallucination problem, I feel like sometimes this is said by people that actually don't have much experience, don't have personal experience, because when we build these things, and if you try them, they may hallucinate, but it is very, very, very rare. Now, it may be that you're in a very high stakes setting, for instance, in a healthcare setting, and you cannot really tolerate any amount of hallucination. But increasingly, we are becoming better and better and better and controlling when the the model is going off domain. So it's going outside of the domain over which it is trained. And there are even ways that you can detect hallucination, and you can be very conservative. So I honestly, everybody that tells me that, I say, I don't think so. That's not your problem. Your problem is probably that you don't have the data ready. If you have the data ready, come talk to us. We can try it out.
And I love your point around, all right, preparing the data, making sure that you're mapping, starting with a specific problem to solve or a use case to, build almost a workflow or a analytical processing flow that would take information stored at a certain element of the agency and produce some sort of a, output or insight that would lead to better decisions. And being able to map that with an organization, Armada, like yours, or a firm that kind of specializes in data-driven strategy, things of that nature, to make sure that whatever analytical LLM or other AI toolkit is being designed to solve specific problems or yield specific outputs. And then I like the idea of the government agencies prescribing specific requirements around controlling information, firewalling, decision-making elements of an algorithm with others, and then being involved in kind of the iteration or training of the model over time. And so I guess any success stories that you haven't mentioned already that have kind of this approach?
Yeah, I can share another one with you, because it is sort of a great lesson in something at home, something that you try to build at home. So we tried to build a chatbot at home for George Mason University, and we have a viable model now, but we didn't start from scratch. We started from open source, an open source llama model. Meta has been very aggressive at open sourcing LLMs. Now doesn't mean that they're truly open source, because they don't show you the pre-training data, but at least the model has the weights. So you can import those weights, and you can have a live model, which you can then continue to train over your particular data. And so we started very aggressive, thinking that here we can collect all the data of the entire university, whatever it resides, and this will be basically George Mason digital. Right. And then we have a version that we call PatriBot. It's a chatbot over George Mason University data. But even inside an organization like Mason, it became very, very obvious that if we wanted to move fast, we had to restrict it to any data that was online, rather than going to specific offices, right, and trying to get their data. Possibly it was there, but it would take months to figure out where the data lies, and how we can digitize it or access it in some shape or form. So we just restricted it to online data, everything from the websites, web pages. We have a very nice, it's not a huge, it's just a couple billion parameter model, but it is sufficient. And it's something grown in-house. It's something viable that is quite specific. We haven't figured out when it hallucinates. Sometimes it goes and it gives you a little bit more detail than you asked it to, right? But it is a beautiful example of growing something in-house. There are a couple of other examples that I can mention, but one point that I think I made earlier, and I wanted to emphasize it, especially for government agencies, I would say be flexible. What I have realized is that I mentioned earlier that everybody wants to do LLMs. So we'll have a government agency, I can't quite name at the moment because it's work in progress, but all they want is they want to apply LLMs to their internal processes and their internal data, and they'll come with a problem, and you'll tell them, this is not a problem for LLMs. This is, for instance, give you an example, it was anomaly detection. This is anomaly detection. You want to find a rare event, and we can build a spatio-temporal model. We can consider that a version of a LLM, but it's not really an LLM, and you don't need it very big. Sometimes when you say that, they think that you don't know what you're talking about, right? That you're not doing the coolest, latest research, because that's what they see, that everybody on LinkedIn, if you follow LinkedIn, is talking LLMs, right? So government agencies need to be flexible, and they need to understand that AI does not equal LLMs. AI is a much bigger scientific discipline. And there are a lot of very interesting problems that are, I would say, classic machine learning problems. They are just very well defined, and we understand them very well because we have been developing them and stress testing them over many years or across many application domains. Some examples from government agencies are very simple. It's probably just have my agents go out in the field and they carry out interviews. And can we basically just have a summarization of that at the end of the day? Those are very simple, right? Those can be done with systems nowadays. All you need is a recording, a voice to text, a text summarizer, and then you can take, as I said, an open source. You can continue to train it over your internal data and able to answer questions. Now, that question of hallucination, you have to know how to restrict the model so that you lower the chances for the hallucination, right? But so there are some very specific low-hanging fruit that the government can do, and then there are more interesting, I would say, AI problems. Some may admit LLM solutions, some may not need LLM solutions.
I think the idea around having having the tool or the approach, the methods align with the problem to solve, and having an expert be able to weigh the pros and cons of leveraging a classic machine learning approach or a network graph model, like you said, with the transportation example, as opposed to a textual language analysis with interview transcribing and theming would be, I think, an important first step as well. Around maybe some of the challenges associated with integrating LLMs and the broader scope of machine learning AI tools available to government agencies, are there kind of specific significant challenges related to data security, privacy, or the integration of custom models with large, maybe legacy systems that are inherent to kind of federal government operations that strike you as being most difficult or most important to address early? I guess what would be the highest priority kind of engineering challenges that you see from integrating machine learning into more government, operational and mission-driven processes?
Yeah, I was smiling when you mentioned legacy systems, right? That's a major challenge with the government. And I've heard it from many, let's call them customers, right? From governmental agencies and industry and companies, that some of them take the approach, we do not want you to build anything on top of, let's say, ChatGPT or GPT-4 or whatever Llama, right? We don't want to because there might be security concerns. But I think part of it is because there is a lack of understanding, right? So these open source models, I would say, are a very untapped territory. You can bring them in-house. There are other challenges there that I think go more to governance issues, and that's because we don't know on what data they were trained. So if there are copyright issues and you bring this system in-house, then it's very murky territory, right? Who's liable for what? You can definitely design your own. Definitely you can design your own in-house. I am just not sure that there's the appetite there for many government agencies. Maybe big ones, yes, but think about local and state government. They don't have the resources, right? Financial resources, computational resources. However, you don't need, I keep telling people, you don't need several hundred billion parameter models. You can have much smaller models for something that you're trying to build in-house. And the way the research is going these days, I see a wonderful opportunity in smaller models. So I failed to mention at the beginning that some of the work we also do in the lab and also other folks in our computer science department here at George Mason is pursuing alternative architectures that are not as hungry for computational resources and data as these transformer-based models that power the LLMs that you hear about these days. But they are approaching the quality and performance. They are tracking very closely these transformer models. These are versions of recurrent neural networks. State space models is sort of one group, one class of these models that are smaller, one at most 2 billion parameters, and they're doing pretty well. They are sort of really getting close to performance of transformers. So you can build smaller models. You can completely build them in-house. The security concerns become primarily the main issue when when you want to sort of outsource, right? When you want to bring a third party in. And that's what I would not suggest, or I would really caution you to read very closely to the contract, read very closely to the fine print on what data is being stored, right? What portion of, because it could be that a portion of the output is not stored. So maybe your prompts are not stored, but the result of the model is stored. And there are all kinds of reasons why companies, the big ones, the big tech want that or justify that, because they can say, well, this is not knowledge that you gave me. This is knowledge that I extracted from my model. It's mine to begin with. So why not? Why shouldn't I keep it, right? And they might be using it in order to improve the model, because you might say, I liked this answer. So they learn and they use that to improve their model and to make it better and better and better, right? So they're getting actually some value out of it. So you need to have someone that understands what is happening. So I would caution you against that. I would be very careful into spelling out what is being stored. Is it prompt? Is it my responses? Exactly, what is that nature of the relationship? Security concerns. There is one challenge with LLMs, that we don't have this tiered security. In cybersecurity, we talked about tiered security. So you may have a system, and depending on, my credentials, I can only access a certain portion, and somebody that has a higher security clearance than me, they can, access some more information. Currently, we don't have this. The current LLMs don't allow us to do that. So, and you can imagine in certain governmental agencies, maybe my supervisor should be able to access more information than me if I'm a few levels down, right? So what are all those tiers of security? But this is very much research, I would say, very important research. And it can be a setting where you may want to partner up with a contractor or with an academic lab, because it's totally doable. But it's still a research question, right? So you would have to kind of calibrate it, what it is that you would be able to do. I mentioned hallucination. You will never be able to guarantee 0% hallucination, but you can really, really minimize it. You can bring it down, and you can have detectors to determine when the model is veering off, when it's sort of the log likelihood score is going down. Then you know what, the model is venturing into a territory, and you can say, I'm not comfortable with that. So you can be very conservative, but you determine how conservative you want to be. In some domains, I have to say hallucination is great, it's creativity, but maybe not in a governmental agency, right? So it really depends on the application. There are more, but yeah.
Yeah, to pause on that, I think what you discussed around lacking kind of tiered security parameters and being able to define almost risk thresholds related to the application under consideration by the agency, I think it's really important to build into the requirements definition process when an agency, federal, state, or local, partners with, for lack of a better term, an engineering partner to help configure some of these models for operational or stakeholder focused use. So we're having a chatbot to resolve questions from attendees or citizens on civic services. Less mission critical and maybe a higher hallucination tolerance than, remote surgery applications that are pulling, you know what I mean? So being able to define, I guess, Armada, would you recommend defining some of those requirements?
Yeah, exactly. You want to understand what are those mission critical settings, right? Because you can have the same system, but you can control the behavior of the system. Because if you decide so when people talk about guardrails, I always want to ask the question, exactly what do you mean? but those guardrails become some very specific thresholds, right? Very specific control points that are maybe informed by the very specific mission, or the very specific maybe sub-agency or whatever it is, the very specific application. It all comes down to control, right? How do you control what the model is doing and what it's telling you, right? And I would say that is an important challenge. It hasn't been demonstrated yet that you can customize, right? It is a version of customization, right? That you can customize what the model allows you to do and what it tells you based on all those thresholds that you have, those sensitivities or those guardrails that you have. But another thing that I want to tell folks is that everybody's saying LLMs, right? I would like to broaden it a little bit. LLMs are very specific foundation models, right? They are very general models, foundation models, but they're only restricted to natural language data, right? Text. But government has way more. Government has images. You have images, right? You have audio data. So the next challenge would be, can you have something that you can train over all modalities of the data that reside in your organization? Because that would also make it very flexible. I don't have to transcribe every conversation, right? I can have audio data. I have plots. I'm trying to figure out how we're doing, right? Graphs that were important. I can bring that into as a separate data modality. So broadening beyond LLMs to foundation models that you can train over many different data modalities, that would be a much more powerful model that will give you a bigger picture of what your organization is doing, and it's much more flexible. We see some examples of those foundation models out there, mainly for scientific research, or DALI, for instance, right? Image to caption or caption to image, all that. But not so much. They're not taught so much in governmental agencies. They're a big research area. How do you build effective multimodal foundation models?
Yeah, well, I guess, Armada, from your perspective, we've talked a lot about LLMs in comparison to other disciplines within the machine learning kind of field of study. Are there non-LLM ML applications that you see are maybe underutilized by government or public-facing applications today that would really provide impact and value to constituents using existing technology?
Yeah. The government. So we've been talking for many years about IT modernization in the government, right? And I was never quite sure what that meant. I would always think, what does that mean? Like latest generation computers, or what exactly is IT modernization? But the way that we're thinking about IT modernization lately at Mason, we're really thinking it's AI. It's AI research. It's AI capabilities. And LLMs, as I mentioned at the beginning, are great. It gets people all excited because, they're examples of the models that can learn over text, right? And what's more flexible and more natural to humans than text. But there are many applications in the government that don't need LLMs, as I mentioned at the beginning. They are very classic machine learning models, whether it is forecasting what's the best policy strategy, right? And it can be reinforcement learning. It has nothing to do with LLMs, right? Unless somehow you want to inject LLMs in the picture for whatever reason. I mentioned rare event detection. This is very important to a governmental agency that is maybe tracking something happening, and then it wants to know, when is something bad about to happen, right? And there are examples of this in cybersecurity as well. So a lot of other deep neural network architectures can be used. But in general, when I think about what comes from the government, I say, okay, what are you trying to do? Is it a prediction task or is it a generative task? If for prediction task, it might not be that you need LLMs. And even if it's in the generative task, so you want to generate data, right? Not just a decision, you want to generate text. And then we have to say, okay, let's see what is the best, how much data do you have, what are those restrictions that you have, right? And then you figure out the right model that meets all of those demands. Now, another area that I think is emerging is, so I talked about multimodal data, but if you think about it, data has different, so data alignment is very difficult, right? So I may have plots. Imagine I'm giving a presentation, right? And I'm talking, and sort of my tokens are coming at regular, maybe 1 token per second if I'm a very fast talker, right? But as I'm talking, occasionally I'm also giving you a plot, but that's not coming at the same, that has some latency, right? So maybe that's coming every 30 seconds, every 3 minutes. So this is an alignment issue because I have a lot of text without images, right? So imagine also some other kind of data, maybe audio data. So data alignment, when you have multimodal, when you want to build multimodal foundation models, that's another issue. Data fidelity is another issue that might not be as much appreciated. Do I trust the plots as much as I trust the text? Do I trust the audio as much as I trust the text, right? Or if I am including data in my agency from some other external source, how much do I trust that data? Uncertainty quantification. So why should I trust what the LLM is telling me? How confident is it, right? Can I give a score to that? that is a huge issue. If I want to make decisions based on that, I want to give it a score, right? I don't want to go to my boss and say, our best strategy is this. And when I ask the question, why? I don't know, because the bot told me so. That's not a good enough answer, right? You need to have some kind of scoring, some kind of confidence, but also maybe an understanding why, right? What are the reasons, so that we can be the interrogators of and be very critical interrogators of what we're obtaining from the bot. And then ultimately sort of this human in the loop, right? It's more, I would say, human is in the driver's seat and then is doing the hard work.
Yeah, well, I think having the human in the loop to define the kind of evaluation or success criteria, or a trustworthiness score. What are the factors that for your organization promote high or low trustworthiness of a model result? Leveraging or curating the data sources informing the model, and then calibrating weights used by the model for a government purpose to align with your organization's values are all direct kind of entry points where humans can intervene and adjust model behavior outside of a computer science or data science programming backgrounds. Are there other opportunities for non-technical staff or decision makers within government or private sector organizations to kind of provide value and help author how models are integrated into their organization's decision making, or collaborate more effectively with technical staff doing some of the programming activities from your view?
Yeah, I would say point number one, don't be afraid. Just don't be afraid. Point number two is talk to people. Talk to academic labs. I mean, you have public universities, right? Here, look where we are. George Mason is around all the federal agencies here, right? Big three-letter names. George Mason could be the R&D arm of all of these, right? So these are really untapped resources. I don't think our public universities get leveraged as much as they should. Many of these government agencies, the main point of interaction is they want to hire our graduate students or they want to hire undergraduates, right? And that's great. That's a modality of giving them knowledge and the technical expertise. But as I said, there's a lot that they can de-risk, they can bring, they can collaborate. We talked about collaboration, right? So don't be afraid, come, ask questions, and be willing to collaborate so that then you can de-risk that research. There's a lot that you can do in-house, but again, you need to talk to the right people so you have a good sense of what you can safely do in-house and what is still in the development stage and needs to be, sheltered inside a research lab and de-risked a little bit more. So there's this spectrum, right? But across this spectrum, point number one is talk to people so you can figure out which is the right modality for what you have in mind or what you'd like to do.
Yeah. And for those looking to get more involved in AI research or integrating some AI capabilities into, business processes, business operations, what advice would you give to emerging researchers or professionals who are, eager to make an impact on their organization through AI?
Yeah, I would say the big point that I tell people is don't let anybody tell you that you can. Don't let people scare you that you can. This is a wonderful age where you don't need to have deep technical expertise. You can actually start. You can teach yourself because of these tools that are out there. I mean, coding is changing so much these days for my students, right? I don't think they write any code from scratch. They start with something and then they build on top of it as they start to understand what it is, what is that the code base is doing. So don't be afraid. You can start. And even in a governmental agency, encourage your employees to go and try out things and then ask them what is it that they found. They can be a wonderful resource, right? So I know that now a lot of governmental agencies are also having their own chief AI officers, right? And everybody's scrambling trying to answer the question, what is it that the chief AI officer should be doing? Right? But I would say you can build a lot of things in-house as long as you encourage your employees. Many of them can be quite creative, right? There's some value that you can get from that and reward that behavior. Don't punish that behavior, but reward that behavior so you can have the first uptakers, right? And the developers so that you can see where people are kind of profiling themselves and then get the best value out of them, but also give value to them, right? Because you have use cases, you can give some use cases, and you can see what is it that your employees are able to do and drive forward for your organization.
Yeah, absolutely. I guess any other kind of macro workforce, impacts that you see AI, delivering as we move forward? I think you had mentioned, reducing barriers to entry for non-technical folks getting into coding or system configuration, other major impacts that you see moving forward?
Yeah. Well, thank you for the opportunity. I think my president would be very mad at me if I didn't mention that at Mason, we have a wonderful graduate certificate in responsible AI. And we have versions of that for professionals. And there's so much interest in that area. It's a short sort of curriculum of just, a few hours. And it teaches you about, what are kind of high level AI methodologies and what does it mean? What does responsible AI mean? And I would expect that a lot of these certificate sort of modes of imparting knowledge will be very appealing for professionals, so they can sort of grab the skills that they want and then go and drive forward innovation for their organization.
Yeah, I would agree. And Armada, outside of the George Mason AI certificate program, are there other sources for listeners to go check out more of your work?
You can find me on GitHub for those that know what GitHub is. Or as I said, we're here in Virginia. We are very lucky to serve Virginia, very happy to serve Virginia. So we just encourage folks to come and talk to us. We're super accommodating. And any questions that you have, or even if it's just, I want to understand this a little bit better. We're a public university. We're meant to serve the public.
Great. Well, Dr. Armada Shehu, thank you so much for joining us today. And thank you for listening. We will be back again next week with more government AI insights. Thanks again, and we'll talk to you soon.
Thank you.
AI, Government and the Future is brought to you by Corner Alliance. To find out more about Corner Alliance and how we work with government to create results, visit our website at corneralliance.com. And then make sure to search for AI Government Future in Apple Podcasts, Spotify and Google Podcasts, or anywhere else podcasts are found. And click subscribe so you don't miss any future episodes. On behalf of the team here at Corner Alliance, thanks for listening.